In this video, we are going to look at the cutting a rod problem. You are given a rod of length n inches and an array of prices that contains prices of all pieces of rod of size smaller than n. Your task is to find the maximum revenue that can be generated by cutting the rod and selling the pieces. For example, consider a rod of length 8. Its different cut lengths and their respective prices are tabulated here. The maximum revenue that can be generated is 22. This is generated by selling the pieces of length 2 and 6 with their total price summing up to 22, as 5 plus 17 is equal to 22. Now let's look at the solution. A simple brute force solution would be to calculate price for combinations of all possible cuts. So the question is, in how many different ways can we cut a rod of length n? A rod of length n can have exactly n minus 1 possible cut positions. That is, we can choose to cut it from 0 to n minus 1 values. For example, a rod of length 2 can have exactly 1 possible cut position, a rod of length 3 can have exactly 2 possible cut positions, and so on. We can choose the k cuts anywhere we want, so that for each such k, the number of different choices is n minus 1 ck. When we sum up all the possibilities, that is for k equal to 0 to k equal to n minus 1, we get the sum equal to be 2 raised to the power n minus 1. This is the sum of the binomial expansion of 1 plus x raised to the power n minus 1 equal to n minus 1 c0 plus n minus 1 c1x plus and so on till n minus 1 c n minus 1 x raised to the power n minus 1. Putting 1 in it, we get the total number of possible combinations to be 2 raised to the power n minus 1. Next, we look at the optimal substructure of the problem. Suppose that we know the optimal solution makes the first cut to be of length k. Then the optimal solution consists of an optimal solution to the remaining piece of length n minus k plus the first piece. That is, let max cut rod n be the required best possible price value for a rod of length n. It is written as follows: max cut rod n is equal to maximum of price of I plus maximum plus max cut rod of n minus I minus 1 for all I in 0 to n minus 1. This means that the best possible price of a rod of length of n is equal to maximum of price of rod of length I plus the best possible price for a rod of length n minus I minus 1, where I can vary from 0 to n minus 1. The formula just defined can be used to implement a recursive solution, but it will have overlapping subproblems. For example, suppose we are asked to find the max cut rod, that is the best possible price for a rod of length 4. So to calculate this, let's have a look at its recursion tree. We cut the rod of length 4 into pieces of length 0, 1, 2 and 3. 3 can be further divided to 2, 1, 0, 2 gets divided into 1 and 0, and 1 gets reduced to 0. We follow the same procedure for the rest of the sub branches. We notice that we have got overlapping sub problems. For example, 0 is calculated again and again, 1 is calculated again and again, 2 is calculated again and again, and so on. Therefore, the right approach for solving this problem is that of dynamic programming. In the dynamic programming approach, we use the tabulation technique that is a bottom-up technique for solving the problem. We form the max cut rod function as follows. We build a table val 0 to n that will contain the values which were recomputed in the recursion tree. We initialize val of 0 to be equal to 0. After that, we build the table in bottom-up manner for each of the possible cut lengths. We use the formula we just studied for filling the table. The last calculated value in the array val is the answer to our problem and is therefore returned by our function.